Hi, everyone. My name is Alex Epstein. I'll be teaching this lesson on MongoDB on how we access the Materials Project database. I'm a graduate student in the Materials Project group in Christine Pearson's group. And yeah, I'm excited to get started in a few minutes. We'll be using 4 different notebooks here. You're welcome to start a fresh notebook if you want, like you did in the Python primer lesson, but we also have this empty notebook called Lessons Unfilled that you can use, and that's what I'll be typing in, and you can follow along there. It has a little bit of extra information. Just to go through the file stream. So if you're back in the home section, you can go to workshop and then primer and then 03 MongoDB part 1. And this has everything we'll be using. So we'll be using lessons unfilled, exercise 1, exercise 2, and exercise 3. And then the lessons filled notebook is also available for you if you want to look at it after, just as notes. There's also solved exercises if you want to look at those after too, or during, whatever you prefer. So we'll start in just a couple minutes. All right, let's go ahead and get started. If you just joined, I'm Alex. This is the lesson on MongoDB, and we'll be using the Nobel Prize dataset to explore how MongoDB works. A few reminders about how CoCal works. You can go to this chat in the top right if you need help, and we have tons of helpers available to help you, and they can go into your notebook and directly help you with code. You're also welcome in the Slack to go to the Workshop 2021 channel and ask any questions there. Cool. So what is MongoDB and why are we talking about it? MongoDB is infrastructure to access databases. And all of the materials project data is stored using MongoDB. So all of the inputs for our calculations and all of the outputs from the calculations to generate data, that all goes into MongoDB, which means that querying MongoDB, so going to the materials project data set and getting information on different molecules and crystal structures is based on MongoDB syntax. So it's super helpful to understand a bit about how MongoDB works in order to interact with materials project software, whatever that may be. So MongoDB is made up of databases, which are then organized into collections, and then those collections are organized into documents. And a document is a data structure composed of field value pairings, where fields are strings and the values can take any of a number of different values, from strings to numbers like integers or doubles to Boolean values, like true or false. They can be null. You can have an array of any of these values. And you can also have other objects, for example, another document. So let's look at an example. Here's what a document might look like for a lawyer named Sue. The string name is the field, and the name Sue is another string, which is the value. But then you can see for can meet, for example, the can meet field has values that is another object. It's another document, which has string fields, Monday, and Boolean values, true or false. If this looks familiar, it's because it's based on the JavaScript object notation, the JSON format. And this is essentially the same thing with this slightly smaller subset of value options. And the JSON format is universal to a whole wide variety of programming languages. It's super useful for doing a lot of different things across different formats and languages. In Python, this is natively supported as a dictionary. If you were in the Python primer lesson this morning, you talked about dictionaries. This has like a field value pair, but they're called key value pairs in Python. Again, you have a string as the key, and then the value can be anything that Python supports. So from strings to ints, floats, true, false, can also be none, just like null. And then dictionaries, having a dict is another dictionary. So that's just like having a nested document, but it's a nested dictionary. And then again, you can have a list of any of these values. So between documents and JSONs and dictionaries, it's really easy to translate between all of these different data formats. All right, so let's start exploring this Nobel Prize data set. And the first thing we want to do is import PyMongo, which is a Python package that will allow us to interact with MongoDB easily. So to do that, let's type from PyMongo, import Mongo client with a capital M and C, and then enter twice. We want to instantiate the client. So client equals Mongo client with open and close parentheses. And then enter, and if we print this client, so print parentheses client, and shift enter on this tab, this cell to run it, we can see that we have a client which is connected through some host, and your connection should be true. So this means we actually have access to the client, which contains the Nobel database. Now, to access the database within the client, there's a couple different ways to do it. One of those is to access it via an attribute. And that means that we can type client.nobel in this cell. And if we hit shift enter, we see that this is a database. So running the cell returns this database that is Nobel. But similarly, like I said, dictionaries are just like the Mongo database format. So we can access it like a key in a dictionary. So we can do client open bracket or square bracket, and then in quotes, type Nobel, close the quotes and close the square bracket. And if we run this cell with shift enter, we get the exact same result. So we get a database, and that database is the Nobel database. Just to assess that these are actually exactly the same, we can do client dot Nobel, and then 2 equal signs to assess if the statement is true. And that check if that is equal to client bracket Nobel, or square bracket. Close the quotes, close the square bracket, and shift enter true. So accessing as attributes and accessing as keys are exactly the same. The same is true of collections, which are, so if you remember, it goes database, and database is composed of collections. So if I type client.nobel.prizes for the Nobel Prizes collection within the Nobel database, that is equivalent, so equals to client square bracket in quotes Nobel, close quote, close bracket, another square bracket prizes. And if we run this cell, we again see that this is true. So 2 ways to access both collections and databases. We can also connect directly to the database and store that as a variable that we can access later. So in this cell, we can type db equals client.nobel, and then enter and just print db to check. So print parentheses db, the variable that you defined. And if we run this cell with shift enter, we can see that we have indeed created a variable db that is the Nobel database. And that's going to be really useful for going through the rest of the lesson. All right, now we can actually access documents, which is the point of storing everything in a database. And the simplest way to do this is to use the find one method. So here, if we go into a new cell, we can use db.prizes. So referring to the database, accessing the prizes collection. And if we use .find one, so find underscore one, open parentheses, and now find one takes an argument that filters the values that you find, or sorry, the documents that you find. So that's an empty curly brace. Later we'll talk about filling those. But if we have an empty curly brace here, which means no criteria, and we shift enter to run this cell, we get one document from the prizes collection, and that is the most recent Nobel Prize in chemistry. And you see this document has field value pairs like we talked about. So 2020 is a string, but laureates is a list, and it's a list of documents. So laureates has 2 people, Charpentier and Doudna, and it has their names and the motivation for gene editing through CRISPR. So this is what one document looks like. But for example, if we want a criteria, let's say we want to look at only physics prizes. So in this cell, let's define criteria equals curly brace, and then in quotes, category. So looking back at find one, category is a field that we can access. And then if we end the quote, colon, space, and then in quote, physics, just like a Python dictionary, we set that criteria, close the brace, enter. We can type db.prizes.find1 like above, but this time use criteria as a filter. And if we run this cell with shift enter, we don't get this chemistry prize again, we actually get physics. Cool, so that's a great method to find one document, but you can imagine you'd want to iterate through documents to find like all of the physics prizes, for example. And the collection that we're accessing is not a list, so it's not as straightforward as just writing a for loop like you would do in Python. Instead, we have to create a cursor. So for example, let's try this exercise, calculating the total number of laureate prizes. So what I always do is if I'm trying to do something like accessing a field to see what the value is, I just use find one to see what I'm looking at. So we haven't looked at a laureate yet. So let's try that collection. So db.laureates.find_1, parentheses, curly brace, to just look at an example. We shift enter to this. We see that this is what a laureate looks like. There's a first name, a surname, born, died, etc. And importantly for us, there's this prizes field. And this prizes is a list of the prizes that they've won. So to get something like the total number of laureate prizes that have been awarded, we want to look at the length of that list. So let's, in the next cell, create a variable count that starts at 0. So count equals 0. And then, as I said, we can't just iterate through the collection like normal. Instead, we use this find function. So cursor equals db dot laureates, dot laureates dot find. And we don't need a filter right now. So find open parentheses, curly braces, as opposed to find one, which we were using before. And now, because we used find, we can say for doc in cursor, just like any other for loop in Python, colon, enter. Now let's define the number of prizes. So I'm calling this num prizes equals the length, so len of doc square bracket, and then in quotes prizes, and the quotes and then the square bracket and the length function. So this will give us the length of this list that we looked at in the find one to see how many prizes are available. Sorry, we're given to that laureate. And then we need to increase the count. So next line, count plus equals to increment it by the num prizes that we just defined. And if we shift enter on this tab, we've now defined the count. And in the next cell, if we print out that count, we get 962. So there's 962 total Nobel Prizes that have ever been given out. Great. So now we know how to find one document and then also iterate through all documents in a collection with find. And we have a good idea of how databases and collections and documents are organized. So with that down, let's do the first exercise. I have it up here, but if you don't have the exercises up, you can go back to the file tree, and inside of the primer directory, there's a O3 MongoDB directory, and then each of the exercises. So you can click on exercise 1. Give everyone a few seconds to pull that up. All right, let's start exercise 1. Let's go through these one by one. So the first question is instantiating Mongo client and connecting to the Nobel database. So try and see if you can remember these fill in the blanks from the lesson, but you can also check back to see what we did in the lesson. This is the same as how we connected before. So I'll give everyone like 30 seconds to try this exercise out. All right, let's go over this quick exercise. So just like before, from PyMongo, we want to import Mongo client. And we have to do this again because it's a new notebook. So we have to instantiate the client again. So client equals Mongo client. Hopefully we don't get an error when we run this. Great. And then to connect to the Nobel database, we go client.nobel. And we can print this client. Sorry, we can print this Nobel database by print db. Shift enter, we see it's connected. So next example is to use the laureates collection to display a document from that. So I'll give everyone another like 30 seconds for this. This is, again, a function that we used in the lesson. Okay, so to get this document, we want to set the document equal to db.laureates. That's the laureates collection within the Nobel database. And the function we want to use is find one to just get one document. And we don't care what the document it is, so we have empty curly braces. And we run this tab to get the document, and we can display its contents by just writing doc in a cell. Shift enter here. We get one document from the laureates. Great. Next exercise. This one is a little bit more involved. It's to obtain a list of tuples containing the first name and last name of each laureate in the database who died in the USA. So this will involve accessing documents and iterating through a cursor that you start. So we'll start that cursor in the first cell and then access, and then create this tuple with a list comprehension in the second cell. So let's take a minute to do this. Okay, so for this exercise, the cursor is slightly more complicated than we went over in the lesson because we need to use a criteria. So we're starting this cursor equals db dot. Again, we're looking through the laureates collection, and we're using the find function to create a cursor. But now we want to make sure that the died country field, so this criteria, is in curly braces like a dictionary, and we want the died country field to be the other side of the colon. We want to make sure that is USA. And the braces and the find function. And if we run this tab, we start the cursor. And now I usually do list comprehensions. I think about the right side of things first. So for each doc in the cursor that we just created, we want to make a tuple of the doc accessing the first name field, and then the doc where we access the surname field inside each of these square brackets. And that creates this names variable. Shift enter here. Now we have a list names that we can run on this cell and get a whole bunch of names of Nobel laureates who passed away in the USA. All right, last exercise for this lesson. Did any of the above laureates receive more than one prize? And if they did, generate a list of tuples with their name and the total number they were awarded, just like in the last exercise, but now with a logical operation within the list comprehension. Take another minute to do this. Okay, so this cursor is just like we had before because we're looking at any of the above laureates. So this cursor is db.laureates.find. We want to make sure that the fields in this filter is diet country and the value in this filter is the USA. And shift enter to create this cursor. And now in this list comprehension, again, we're iterating through for each doc in cursor. But now we want to make sure that the length of the prizes field. So if you remember looking at one laureate before, this prizes is a list. So the length of the list is going to tell us how many prizes they got. So if the length of doc prizes is greater than 1, we want to add their first name by accessing the first name field, and then we want their total number they were awarded. So in this doc, we want to get the length of prizes. Shift enter to generate that list of names and prizes, and then we run the cell to get their names. So John and Linus both won 2 Nobel Prizes of laureates who died in the USA. Great. Hope those were some useful exercises. Let's get back to the lessons now. So if you scroll down in the lessons unfilled or whatever you're using, you're welcome to use an empty Python notebook again. Now we're going to talk about listing and counting. So to do this, just to review and in case something happened to the connection, let's import Mongo client and start the client again. So from pymongo, import Mongo client. Enter, enter. Set this client equals Mongo client, parentheses, and we'll print client just to ensure we have a good connection. So here we go. The connection is true through the local host. We're all good. So a reminder, once we start working on listing and counting, that the lowest level of information is a document. Documents are organized into collections, and then collections make up a database. So if we want to answer the question, how many databases are managed by client, we can use listing functions. So let's create a variable called db_names and set that equal to client.list database names with parentheses. So underscores between list database names as I wrote. And then we'll print DB names. So look at those names and that parentheses. And you can actually do the same thing to collections. So while we're in this cell, let's do enter, enter, create a new variable for the collections. I'm going to call it Nobel underscore COLL underscore names equals client dot Nobel dot list underscore collection underscore names with parentheses. So here, because we're looking at collections under databases, we want to access the Nobel database as an attribute and then list the collection names within the Nobel database. We'll enter, print, parentheses, that variable that we just created, Nobel call names. And if we run this cell with shift enter, here we see the first list is a list of database names managed by the client, which is a really good reference to just check where you are in a database. So there's a bunch of databases we're not using, and then there's the Nobel database, which we are using. And then if we look inside the Nobel database, the next list is printed the collection names. And so there's 2 collections. We've been accessing these throughout the lesson. One is laureates, and the second is prizes. So next, let's count documents. So within a collection, how many documents are there? let's first create this DB variable that we can look at again, or we can access easily. So DB equals, oops, too many spaces, equals client.nobel, and shift enter to run this cell. Now we have this database to access. And let's ask a question: how many laureates were born in Egypt? So we had this loop that we ran through before to count, but there's a much easier way with a count documents method. So to see if they were born in Egypt, I always just check what the documents look like with find one, like we did before. So I'm going to type db.laureates.find1 parentheses, curly brace that's empty, just to get an example. Shift enter to run this cell. So if I want to see where someone's born, I need to look at the born country field. Cool. Now, if I want to count documents in which to see how many people were born in Egypt, I can do db.laureates.count_documents. So that's the count documents method to count documents. Parentheses, curly brace to create this filter. And then the field should be born country, like we just saw from looking at one example. And that string, have a colon for the next string in quotes, Egypt. End that quote and the curly brace and in the parentheses, and shift enter on this tab, and we see that there are 6 Nobel laureates that are born in Egypt. What if we want to create a more complicated filter to ask a more complex question? So for example, how many laureates were born in Egypt and died in the United Kingdom? Now we need to create a filter that filters twice. So let's create this variable criteria equals curly brace. The field is died country, end quotes, United Kingdom, in quotes, and then a comma. So this is like a dictionary. Sorry, I have a typo I just noticed. You should have a colon between your keys and values. And then to separate different key value pairs, you want a comma. So died country, United Kingdom, comma, in quotes, born country, end quotes, colon, and then in quotes, Egypt. And the quotes and the criteria filter. Now if we enter and we make this count, so count equals db.laureates.count_documents, and we filter with this criteria inside the parentheses, and enter and print this count. If we run this cell with shift enter, there's only one. Just as a fun fact, in the next cell, if we do db.laureates.find1 parentheses, curly brace. Sorry, we don't need a curly brace because we've already defined this criteria. So just use the criteria variable and the parentheses and run this cell with shift enter. You can see that it's Dorothy Hodgkin, an extremely important person in the field of material science. Was born in Egypt and then moved to the UK. Fun fact. All right, that's the end of lesson 2, which means it's time for exercise 2. I already have it open, but you can navigate again through the folder to get to exercise 2. All right, for exercise 2, we need to instantiate Mongo client and connect to the Nobel database again. And then let's look at a document from the prizes collection. So these are both lesson 1 topics. So let's take 45 seconds to do both of these. Or a minute, take a minute. Okay, hopefully everyone is connected successfully. I'll just go over this again. We want to, from PyMongo, import Mongo client, and then connect to that client by calling an instance of Mongo client with parentheses. Run that cell with Shift Enter, and then access the database by creating this DB variable where we access the Nobel database through client.nobel, and then print that DB to make sure we are successfully connected to the Nobel database. All right, then let's look at a document from the prizes collection. We've been working a lot with the laureates, so let's review what this looks like. So, right, accessing a collection means taking this db.prizes.find1 lets us look at an example document. And then inside this, we don't need a filter, so open and close curly braces, close the parentheses, and now we've defined this doc variable to be a document. And if we run the next cell, which is just doc by itself, we can see this document. This is what prizes looks like again from the beginning of the first lesson. It has a year, a category, and then a list of laureates. So let's go to a slightly more complicated question, which is using count documents to define which of the following statements is true. So we're trying to see how many laureates there are with respect to how many prizes have been awarded. Take a minute to work on using the count documents method to answer this exercise. Okay, so to answer number 3, first we want to count the number of prizes. So we set this num prizes variable equal to db dot prizes, the prizes collection, and we want to count the number of documents and prizes. This gives us the number of prizes. Oops. All right, so I got an error. Count documents missing one required positional argument filter. So that means that I didn't put a filter in, as I've been talking about, and I forgot to do it. So let's put curly braces here to represent an empty filter. And now if I run this cell, no errors. Cool. And we can do the same thing with laureates. So the number of laureates, we go into db.laureates.count documents. This time we can put an empty filter in so we don't get an error. And we run this cell, and we get a number of laureates from counting the number of documents in the laureates collection. And then to answer this multiple choice question, we can take the number of laureates divided by the number of prizes. And there's 1.46 number of laureates per prize. So that would mean answer D is correct. The laureates outnumber prizes by less than 2 times. Now this doesn't have another number, so I don't know if people did it during the last one. But we'll give 30 seconds to do this in case you didn't do it with number 3. And that's doing a similar exercise, but now with actually creating a filter. So looking at the number of peace prizes awarded in 1911 versus born country, Finland. Actually, just realized that this is slightly incomplete. If we're specifically looking at peace prizes, then we need this filter to have 2 criteria. So we need to make this dictionary have 2 things, just like when we looked at born country and died country before. So you can make that change on your own. Right? So this was a slightly more complicated exercise with peace prizes being the question that we're asking. So first, number of prizes. We go into the prizes collection db.prizes.count_documents. And we want to make sure that the year, the field is 1911. So the value is in quotes 1911. And we also want to make sure that the category field is quotes peace. Yes, peace is lowercase. I scrolled back up to check and to find one. We run this cell with Shift Enter. We've calculated the number of prizes. The number of laureates is going to be a bit more complicated. If I create a new cell to look at db.laureates.find1, oops, Shift Enter, run the cell manually. Here we see that to get the category, it looks like we have to go into prizes. So this should look like db.laureates.count_documents like before. First, we're checking who was born in Finland. So born country is the field and the value is Finland. And now this criteria is a bit more complicated because we want the prizes .0. We're getting a little bit ahead of ourselves in this lesson. Yeah, this was just an accident in making this more complicated than it needed to be. But we're going to look at the first element in the prizes list and the category. We want to make sure that's peace. And Shift Enter to run that. And if you didn't get that, that's fine. We haven't gone over it. So then the number of laureates is greater than the number of prizes is false. So there have been more prizes given out than there are laureates. Sorry, there were more prizes given out in 1911 for peace than there were prizes for peace given out to Finland. All right, let's go to lesson 3, in which we will actually learn how to use dot notation. Let's go back to lessons unfilled to start working on that. And import Mongo client like before. So here from pymongo, import Mongo client, enter. Let's set client equals Mongo client with open and close parentheses. Set the DB equals client.nobel so we can access that later. We've been doing that later, but now just doing the first cell. And print parentheses the client and parentheses, oops, typo. And print again, parentheses, the database to make sure we're connected to both. So we have a true connection to the client and we have the Nobel database saved as DB. Let's talk about query operators, which really help in finding. So query operators can help us construct much more complicated criteria. And as a first example, we're going to look at the in query. And so in helps us answer questions like how many laureates were born in any of Canada, Mexico, or the USA. So to create that criteria, we say criteria equals, and then with a brace, I want to set first, we want to make sure the born country is the field we're looking at. And then the way we use an operator is that colon, and now the value, the key or field for the value is this in operator. So the $ tells Mongo that it's looking at an operator, not just looking at the string in. So in colon, here we have a list with square brackets for a list in Python. Now we have a string for each country. So Canada in quotes, and spelled correctly, Mexico in quotes, or the USA in quotes. And the list, and the operator, and then end the criteria as a whole. And so we want to count this to see how many laureates were born in any of Canada, Mexico, or the USA. So we set the count to be equal to db.laureates to get the laureates collection, .count _ documents, like from lesson 2. And that takes criteria as a filter. And the parentheses, enter, and now we print parentheses count. If we run this cell with shift enter, we can see there are 302 laureates that were born in any of Canada, Mexico, or the USA. Great. Another really useful example of a query operator is the not equal operator, NE. And this can answer questions like how many laureates died in the USA but were not born in the USA. So to do that, we create a criteria again. So criteria equals curly brace. First, we want to make sure that the first field died country, in quotes, is the USA. And so in quotes, USA. And the second item in our criteria dictionary, separate that with a comma, in quotes, born country, end quotes, colon. And here's where the operator comes in. We have a dictionary for the operator. The first field in quotes is the not equal operator, $NE, and the quotes, and we want to make sure it's not equal to the USA. So that was colon, and then in quotes, USA. Then we end the braces for the operator, and then we end the braces for the criteria. We count as usual, count equals db.laureates.count _ documents, and that takes criteria as a filter, and the parentheses, and we print count and shift enter to run that cell. So there are 72 immigrants to the US who won Nobel Prizes. Here's a list of some more comparison query operators that are available, and this might be helpful for the final exercise. Exercise 3, equals to, greater than or equals to, in, which we used, less than and less than or equals to, not equals like we used, and not in, which is matches none of the values specified in an array. So if I wanted to check, how many people were born not in Canada, Mexico, USA, were born anywhere else in the world, you can do that with not in. In addition to comparison query operators like we've been talking about, you can also use logical query operators. And to answer questions like how many laureates died in the UK or were born in France. So here we set criteria equals curly brace quotes $or. So here the query operator is the beginning of the criteria that you define. And you end the quotes and now colon. And so these logical query operators take lists. So the first, it's going to compare the different elements in the list. So we create a list with a square bracket. The first criteria we're comparing, we put in curly braces and we say We want the died country end quotes. We want the died country colon to be France. End the quotes and that criteria. And we want to compare this or, so the next element in the list, curly brace in quotes, or the born country end quotes colon is France. End quotes. I just realized that I said this was France and it's Canada. Let's fix that. So this field we're looking to be Canada. And this or list can be as long as you want. You could say born in France or, born in Jamaica. It could keep going. So end square brackets and the curly brace. Let's get the count like we've been doing. Count equals db.laureates.count underscore documents for the criteria and the parentheses and print the count and parentheses. Run this tab with Shift Enter. So 60 laureates died in Canada or were born in France. And there's the main logical query operators are all available in MongoDB, and, not, nor, and or. So the final query operator we're going to look at is regex for text searching. This is my favorite query operator. I use it all the time when I'm working with the materials project database. And what this does is it allows you to do text searches. Regex stands for regular expressions. It's used throughout a ton of different programming languages, and it's a pretty powerful way to pattern match within text. And we're not going to get really into how the pattern matching works. We're just going to use it for simple text searches. So to see how many laureates were born in 1879, I'm going to take a look at what laureates look like again, because I forgot. So db.laureates.find_1, parentheses, curly brace to have no filter, and let's Shift Enter to run the cell. Okay, so the born year is this longer string. So if I wanted to match, I could figure out just by looking at born if someone was born on March 27th, 1845, but just to see if they were born, how many people were born in 1879 in general, I have to use this regex text searching. So in the next cell, I'm going to create criteria equals open brace in quotes born, looking at the born year, colon, and now I have the query operator dictionary, and in quotes, I'm going to put this regex operator, end quotes, colon, then in quotes, I'm looking for the string 1879 or 1879 and then a dash, whatever works to match this part of the born year. So in this case, it's 1845 dash, but I'm looking for 1879 dash. And then I end the operator dictionary, and then I end the criteria dictionary. And now we can count equals db.laureates.count_documents. And this, as usual, takes the criteria as an argument and the parentheses and print the count. So there are 6 laureates born in 1879. So with regex, we were able to search within the value to identify a string. Great, so last section of the last lesson is using dot notation, which was hinted at in the last exercise by accident. And we can use that to answer questions like how many laureates were awarded at least 2 prizes. So we addressed this in the first part of the lesson, but this is a efficient and kind of more powerful way to do this. So let's take a look at an example laureates document. db.laureates.find1, parentheses, braces, Shift Enter. So prizes is a list. And to see how many laureates were awarded at least 2 prizes, instead of taking the length of this prizes list, instead we could see if the second element exists. So the prizes only has 1 element if only 1 prize was awarded, but it will have 2 elements if 2 prizes were awarded. So here we'll also use the exists operator in conjunction with dot notation. So let's make a criteria. Set that equal to, in braces, quote, prizes dot 1. And this is what dot notation is and what I used earlier. So here, prizes is accessing the prizes field, and the dot one, it's 0 indexed, like all lists in Python. So 1 gets the second element of the list. So we're looking at the field prizes.1 end quotes, colon, brace for the operator. And then here's a string with $exists for the exists operator, colon, true. And true is not a string because it's a Boolean. So if it does exist, it will return true if it exists at all. So this is telling us if there's a second prize, then laureate has 2 prizes at least. And the brace and the next brace, enter and count. Count equals db.laureates.count underscore documents. And it takes parentheses criteria as an argument. After the parentheses, we can print parentheses count. Shift enter to run this cell, and there are 6 laureates that have at least 2 Nobel Prizes. Now the idea of using dot notation becomes really powerful if you're doing something more complicated, like how many laureates were awarded at least 2 prizes specifically in physics. And so here we set the criteria. Here, let's actually just look at what this would look like to compare in dictionary notation. So db.laureates.find_1 for the criteria defined above. So we just get one where the second prize exists. Now, dictionary notation in quotes, square brackets, quote, prizes, end quote, and square bracket. We're looking at the first prize, so taking the 0th element of this list. And in square brackets, we're looking at the category. So that will return physics. So we can see this is how we're looking for what the category was just with dictionary notation. So if we want to translate that into dot notation, let's create criteria, a new criteria equals in braces. First field is prizes.0.category. So make sure the first prize, end quotes, colon, is physics, end quotes, comma. Now we want to look at the second prize. So prizes.1.category, end quotes, colon, and then in quotes is physics. So this makes sure that both prizes are in physics, and we end the brace to end criteria. We count like usual. Count equals db.laureates.count documents, taking the criteria as an argument. Enter and print the count. Enter, so 1. Let's look for fun at who that was. So db.laureates.find1 with this criteria. Shift enter. So using the same criteria for find_1, you see that John Bardeen has 2 Nobel Prizes in physics. Pretty cool. All right, now we can synthesize all of this knowledge into doing exercise 3. So if everyone can go to exercise 3. For the sake of time, let's quickly import, like usual, from pymongo import mongo client and set client equals mongo client with parentheses. Shift enter to run that cell, and then create a variable we can access db with. So db equals client.novel. Run this, we're connected to the database. And now let's take an example using the not equals operator. So find the total number of laureates who died in Canada and were not born in Germany using not equals. So let's take 45 seconds for this. Okay, so for number 2 in exercise 3, we want to set criteria equals so that in quotes the died country, and the value is in quotes Canada spelled correctly. We want the born country, so born country is the field, colon, and then here we're using the not equals operator. So another curly brace to represent the to support the operator, $NE, and quotes, colon, Germany, in quotes, braces to end the operator, braces to end the criteria. And we can run that to count the documents, and we can run the next cell to print the count. So there are 5. Great. This lesson is almost over, and there's 1, 2, 3, 4 slightly harder questions. So let's skip to 6, because it's like the culmination of using operators and dot notation. It's a little bit complicated. So let's estimate the number of laureates who are awarded a prize affiliated with the USA, but were born in a different country. Use only the first prize and affiliation in each respective array. So when using dot notation, you can just use the first. And here's an example of what a document in laureates looks like. So let's take a minute to do that, and then we'll wrap up. And as I said before, the solutions to all the exercises are in this directory. So you can access them after if you want to on your own time, do the other exercises or the other questions in this exercise. Okay, let's go over this quickly. So the first thing we want to do in this criteria is make sure the laureate was not born in the USA. So this field is foreign country, end quotes, colon. Then we have this not equals operator we need because we want to make sure they weren't born in the USA, $NE, end quotes. Now the second element of this filter, we need to access lists within lists. So first we want to look at prizes, .0 to get the first element. Within prizes, within the first element, there's affiliations. So we want affiliations. Affiliations is also a list, so we want to look at their first affiliation. And we want to look at the country of their affiliation. We want to check if that is the USA. So prizes.0.affiliations.0.country is USA, and we count that. Enter and shift enter on the count. There's 117. Cool. So thank you for listening into this lesson. I hope you learned a lot about how to use MongoDB, and that will carry into being helpful throughout the rest of the workshop. Thanks for your time. Have a good rest of your day.